DNS Resolution. We've looked at DNS resolution in detail in this series of videos, but now let's take a detailed look at DNS resolution from a client's perspective. Suppose we have a user that's attempting to visit the winstructor.com website. Now currently it doesn't have any knowledge of the IP address of our website, so it can't go straight there. So the first thing that the client will do is check a local text file stored on its hard drive called the host file. Now this file is simply an ASCII text file that stores only host records. Now if the address for the Winstructor website is found, the client will go straight to the website directly, and that's the end of DNS resolution. Now your host file can be found in your Windows directory /system32/drivers/etc. Now the host file is simply a file named host with no extension. So if we open up our host file, and we'll use Notepad to do this, you'll notice that we only have one entry here currently, which is for our local host. Now if we wish to add an entry for winstructor.com, we could simply type in the IP address followed by winstructor.com, and then our client will certainly be able to find the website. But what happens if our IP address of the website changes? Well, in that event you can be sure that you won't be going to the correct place. Now as a side note here, you can actually enter in information that's not correct. So for example, I could type in here an IP address for winstructor.com, and over here I could enter in something like microsoft.com. And now if I save this and go to a command prompt, and then I'll ping www.microsoft.com, you see it responds with 192.168.0.10, which of course is the IP address of our DNS server here. So in essence what this means is users on this host that attempt to connect to Microsoft.com will in fact be redirected back to our Winstructor website. So be careful when writing entries into your host file, as it does override all, at least as far as this individual client is concerned. Now in the more likely event that the address is not found in the host file, then the client will check its local cache to see if it has the address there. Now this will only happen for a Windows 2000, XP or 2003 computer. If the computer is running Windows 95, 98 or NT, then it will go straight to the DNS server. But seeing as this video is concentrating on Windows 2003, we'll stick to discussing DNS resolution for Windows 2003. Now a Windows DNS client will cache a name and IP address, and each will have a time to live or TTL in seconds. Now this means that this client will keep a copy of this record in its cache for this amount of time. Now when this time expires, the record in the cache will be deleted and the client will have to look it up again. Now quick point to make about caching. It's quite logical to associate caching with successful DNS resolution, but consider this. Let's say that we've just built a new server and we called it fileserver.winstructor.com. Now from our client we ping the server, but it fails to respond. So we go over to that machine and we realize that we'd configured it with an incorrectly spelt host name. So let's say we just called it fileserver1.winstructor.com. So what happens is now that we correct the host name and then we reboot the server. Now from our client we try to ping the server again and we get the same failed message. So why does this happen? Well, this is the result of negative caching. When your client caches addresses, it caches both successes and failures. When we tried to ping fileserver.winstructor.com, it failed, and our client cached the failure locally. Now when the problem is rectified and we again attempt to ping the server, your client checks its cache and it finds an entry there. This entry says the hostname doesn't exist and the ping fails without actually having been attempted. Now you can verify what DNS entries your computer has cached by typing ipconfig/displaydns at a command prompt. So to solve this problem of negative caching, we have three solutions, although really only one of them's practical. Now the first thing we could do is add a host file entry. Now this would indeed solve the problem, as our host file will be checked before the cache, and having this entry will allow us to ping the host. Now another thing is that when we use this method and successfully ping the server, our local cache will then be updated and future resolution will in fact work even if we then go and remove that host entry. Now whilst this host entry option will work, it's not a desirable solution for reasons that we've mentioned earlier. The second option is to wait until the time to live on the cache record is up, and then the record will be expired and deleted from our cache. Now sure, this will work too, but who wants to sit there and wait, especially if you need access to this server now? Now the final option is to run the ipconfig/flush DNS command at our command prompt, and this will clear out the cache, and now when we ping the file server, our ping will succeed. Now a final note here, when you do clear the DNS cache on your client using the ipconfig/flush DNS command, if you run the ipconfig/display DNS command immediately afterwards, you'll notice that there still are some entries listed. Now these entries are whatever entries are in your host file. Okay, so after the client checks the host file, then its local cache, then contacts the DNS server on UDP port 53 and asks it for help. Now in the same request for help, the client also sends the DNS server a port in which to send the response back on. The DNS server then checks its cache, and if it finds a match, it sends a reply back to the client on the requested port. However, if the DNS server doesn't have the information cached, it checks the name against its zones. Now a zone is simply a portion of a contiguous namespace in which a server has been given authority over. Now you wouldn't expect to have a zone on your DNS server for winstructor.com, although you certainly could. So unless this request is for a host inside your own domain, then it's unlikely that the answer will be found here. So if the zones do not contain the required information, the DNS server attempts to contact the DNS server that is authoritative for the winstructor.com domain. Now as it doesn't know the IP address of the DNS server for winstructor.com, it will attempt to contact the next best thing, its parent. Now as it doesn't know the IP addresses of the .com servers, it checks its root hints file for the IP addresses of the root servers and then attempts to contact them. Now the root DNS servers do not know the IP address of winstructor.com, but it does know of another server or servers that should know. So it sends back the IP addresses of the DNS servers that are authoritative for the .com domain. So our DNS server sends a request to these DNS servers. These DNS servers do not know the IP address of the host that we wish to contact, but they do know who should know this information, and that is the DNS server that is authoritative for the winstructor.com domain. So this IP address is then sent back to our DNS server. So our DNS server contacts the winstructor.com DNS server and asks for the IP address of the machine named www on the winstructor.com domain. So the winstructor.com DNS server responds and sends our DNS server the IP address of the web server, and then our DNS server caches that information locally. So our DNS server then forwards this information back to the client on the port that it requested when it sent the original query. And now our client can contact winstructor.com's web server directly, and then it will retrieve the web page. So in a nutshell, that's how DNS resolution works. It's important to have a good understanding of how DNS resolution works, because armed with this information will certainly help you troubleshoot both client and server name resolution problems.